Okay, I didn't have audio. So, so whoever was watching hasn't heard a word I've said, but that's okay. Is that where I'm at? So, oh wait, where's Matt at? So to repeat myself, you know, when you make a mistake, you shouldn't get like panic or disgusted at you. This is a weird statement. You should expect to make mistakes because everyone does. The second thing is, this is where I got most of this experience, programmers make loads of mistakes. So what they will do is they will often structure the way they do things very well so that they go under the assumption they're going to make mistakes and then structure it so they can easily find it. If you look at it, that's where the birth of object-oriented programming came from. It didn't come from objects or widgets on the window. It came from the fact that they wanted to modularize everything so that they could easily find their mistakes. So if we start with this concept and say, you're going to make a mistake. If I'm a teacher and I'm not making a mistake, I can do that. I can sit there and spend an extra hour before class and write everything out that I'm going to say exactly and just copy it from the paper. That doesn't teach you how to handle things. So I've made a mistake. I don't know where it's at. But I can kind of track. I'm pretty sure I'm okay here. So D1 and D2 might be a thing. I feel comfortable that these are okay, but I need to scroll back up and make sure I didn't goof them up. So scroll back up so I can see them. Oh, I scrolled too far back up. Sorry. D1 is D1 this way? Oh, okay. Okay. So there's I'm okay there. So I goofed that one up. Actually, okay, so here you go in a programming sense. How could I have done this so that my chance of programming it would have not made a mistake? So did you catch that early on, or oh, you didn't? So let's see if I can run back to that. Okay, so now what I'm going to do this. Since they're both the same number, this is what someone that's a programmer might do. So you do like that. So you only have one thing to look at. So that's a good example of, this is the same, that magnitude is the same on both. And so a programmer who is used to catching his or her mistakes, will always look for that single entry point. You're looking for first of all, you really want to look for the minimum number of calculations to get yourself from A to B. Because the more times you hit the keypad, the more chances you're going to make a mistake. So if you're hitting the keypad on your calculator, and I do 24, enter it one time, then that would have reduced my probability. But obviously I didn't. I goofed it. So I think everything I wrote here was fine. I think this part is the part that's not fine. And so now let's go back and add it. Okay, first I got to add it. Then I got to take the norm of it. Did I do the same thing? 22.7247. So I think I'm okay now. So you could have done it either way. And the thing is I know often, and I have a commentary which is probably inappropriate, but I think the way academia runs now is slightly off kilter because in the classroom, everybody, there's a teacher, they say everybody's focused on grades, but the system is biased that way now, whereas before it was not. The reason it's biased that way is there's scholarships that are based on grades. Then what happens is the scholarships force you to take the number of hours that they want you to take in order to keep it. So sometimes the scholarship might, for some people, not all people, might be a hindrance for their learning, but an advantage for their finances. So I don't know. I don't know the answer to it. Back when I was taking, there wasn't those type of restrictions. You know, you, I don't know. I don't understand. You know, I understand the way things are and stuff. But what I'm saying, what I was getting at is if you have, my mind started with this concept, if you have a chance and the time, which sometimes you don't because you have too many classes, then you can work it both ways and you don't have to see the back of the book before you find out whether your answer was right or wrong. Now I feel fairly confident that that's the answer because I've worked it two independent different ways. Now we got to find what was the distance to the boy to the girl, right? Was that right? So you could do a couple things. One thing you could do is you could find this angle B, add 25 to it. That'd give you the angle from here to here. I don't remember, oh yeah, here it is. This is 114. So if I had this and I had that, then I'd be able to make a triangle between here, this line, which almost looks like it's in the same direction, and the other. So let's try that first. First B, okay. So sine of B over B is equal to the sine of the little c, which is that, and then the big C, which is now, this is 22.7247, because I got that. And then this is the sine of the C is directly opposed to it. What did we figure? That was 70. And then on this side, the B is 11, and then the sine of the little b. Am I making sense? So I'm basically, I should have put an equal sign right there. So I'm basically looking for this angle. I'm going to add 25. That's going to get me the direction from here. Then I could add 114. That gives me the angle between those two. I have a feeling it's going to be fairly funny, but we'll find it out. So B is equal to the inverse sine of 11 times the sine of 70 over 22.7247. So I have no idea what that's going to be. Okay. Okay, now I'm so far from it. Arc, sine, and degree of 11 times the sine and degrees of, is that 70? It's got to be 70, isn't it? Oh, I forgot to put the, yeah, parentheses 70. You know what? Here. I'm going to do this to be wrong. Okay, here's what I'm trying to do. Okay, I know I'm going to be wrong, and I'm going to do that, and then I'm going to do this. So there was the normal B. So I'm going to carry that as long as length of C equals 2. And now I'll go back up, and I'll kind of try to complete out what I was doing. 70 divided by length of C, because I just didn't want to type that in. So in other words, I didn't want to make a mistake again, so I carried the LC being that, so I could slip it under there. So I'm trying to, that's another, if your calculator can use variables sometimes, then you don't have to retype all those digits back in, less of a chance of mistake. 11 sine of D, okay. 27.05, oh God, I'm tired, 27, maybe I'll just say it's 27, 27.0, all right, I'll carry 561. And then if I add 25, and then if I add 114, what do I get? That will be, this is gonna be ridiculous. So now that I got that, I'm gonna go back up, I'm going to add 25 and then 114. Was that what I was supposed to add? 25 and 114. So I got 166. So So what I got is a vector that goes here and a vector that goes here. And I want to know the distance between these two. The total thing that swung out was 166.0561. This distance was now 22.7247. And how far did she walk? Is that what it had to be? That's the only number I have left. So it's 8.5. So now I've got the situation where I can go here, 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 and across. So at that particular point, I can just use the law of cosine. So I can find this as some, I hate to use it because I've already used C, so let me just say this. This is going to be square root of that squared, minus 2 times that, times the angle, cosine of the angle between it. So in other words, 22.7247, law of cosines again, 18.5 squared minus 2 times 7.2. I'm too tired to write the last 4 digits there. And then 18.5, and then times cosine of 166.0561. Now, before we go too far, I'm going to do it the other way too. So because I'm doing it the other way, you know, I'll have something to check against. So I'll just come in here and, all right. So now let's see if I can work on my vision so I can see this. Okay, square root, so I'm looking at the angle, so square root of, oh geez, I wish I could, you know what, I have length of C, you know what I should do? Length, I'll just say L is equal to 18.5. You'll see why I'm doing that in a minute. Square root of LC squared plus L squared minus 2 times L times LC times cosine in degrees of 1, I don't know, I'm too tired, so it's 166. How about that? And what do we get? 40. Now, does that make sense? Let's think about that. The most it could be is that number and that number, meaning these are gone. So 1840, is that even legitimate? It's 22.72 and 18. This is the most it can be to, so it's a 12, okay, it's 8, 19, it's 1, 3, so it's 4, and that's the most it can be. So it looks pretty close. That makes sense because it's 166, almost 180. If that's 180, you can do the math if you want to. I'll just add these two numbers and I'll get the same thing. So that's the most that can be. That's pretty close. I feel comfortable. Okay, so let's do it the other way. Now I still have D1. I still have D2. I think I called the other one D tree to the boy, DT. So I labeled it like this, DTB in MATLAB. That's what that one was called. And now I'm going to add the vector. So if I'm, okay, so let's do it like this. I got a vector. I'm going to make them not 180 degrees so it looks easier for me to draw. So I've got a vector D tree to boy, and I got a vector over here D tree to girl. Okay, and I want to add them. I want to find the distance between them. What happens if I add them? Let's think about that for a minute. If I'm adding them, I want to know the distance. So this is where it could get tricky. If I just add these, if your just first thought is to add them, D tree to boy. And then this, you're going to get this distance. That's not really what you want. Am I making sense? So what you really want, you want to sit here and say this. This is a D tree to boy. This is the D. I'm changing the direction so I can make the vector look. D tree to girl. Now I want to find this, which is not the addition of D tree to boy plus D tree to girl. This is D tree to, or the question stated, the boy went now on a vector path to find the girl, which is this. So this is the new vector. This is rescue, R-E-S. Assuming it's a rescue, I don't know. I don't know what it is. I'll just say RR. That's where he went. So implied there would be tree to boy plus RR equals D tree to girl, which means that what we're actually looking for is this. We're looking for the difference between them, and we're looking for the size of that vector. So I think I already have D tree to boy. Okay, there's my two values. I do not have D tree to girl, but I can come up with that. D tree to the girl is, and I'm gonna basically, what happened here? Oh, okay. I'm gonna basically use what I was talking about before. I know the distance was 18, is that right? 18 and a half. And I know this is the angle. So I'm gonna put the 18 and a half in the front. Times now, I'm either gonna have to have a cosine or sine. Now here's the thing. The vector was like this, and it was 114. Is that legitimate? Good question, because actually, if you look at the cosine, you're going to dip down to here. You're going to dip down to here. Here's your 90. Here's your minus 90. Now, I know for a fact this is going to go in this direction. So if I do a cosine of minus 114, what am I going to get? And so I can just sort of put that in there. Of course, the sine. The other question is the sine. So here's your sine. There's your 90. And say, I'm just making this up. Here's 180. So here's your minus 90. Here's your minus 114. So it's a minus. And lo and behold, it goes like that as well. So, but I'm going to be a little bit more, I just don't want to make a mistake. So what I'm going to do is I'm going to do this. I'm going to break it down. Say, what's 90 minus, was it 114? 114. So that's 24, right? So I'm going to do this. Okay, this is just the way I do things. Okay, it's 24. If I want to project that back to here, that's just going to be cosine 24. But that's in the minus. So if I'm looking at this, the vector itself, 18.5 times the vector, looking at the cosine, looking at the y, that's going to, I sure did. It's supposed to be sine. And then cosine degree of 24. And again, I forgot my minus. So I got a minus going to the left and a minus going down. That seems to be larger. That sort of makes sense. If I was 45 degrees here, they'd be equal. The fact that I'm 24 means this one should be a little larger than that one. So I feel moderately comfortable. Now what I want to do, it doesn't matter which one you subtract these from. You just want to take one minus the other, and that's it. And then take the norm of it. So what I'm going to do, I'm going to try my best. Norm, D, tree to the girl minus D, tree to the boy. 40.82, no, I'm sorry, 40.92. That's, I think, what we got before, wasn't it? Did I ever write it down? I don't think I ever wrote it down, did I? So I have to scroll backwards to find it. Okay, there it is, 40.9207, 40.9231. Which one would be more accurate? I don't know. I don't think I typed in all the digits right there. I think I did 166 and just got tired. So if you look back, it's probably closer to this one than it is the other. So it's about 40.92 meters. So I know this was like I've just been a rabbit, running around a barnyard for a while. And I'm sorry I didn't turn the audio on, but I did turn it on halfway through. So if you want to go back and look at this, you can. But really, I guess you don't need much of the audio that much, except, you have to be able to understand that I made a mistake, and then I went routinely back and tried to fix it, and past that. So anyway, I guess I'm done. Sorry I made a mistake, but hey,